Hi, I'm Ms Hearn. Let's get started. And if you find this video helpful, please remember to give it a thumbs up. That helps other students to find the video. Now let's look at finding the derivative of y equals the natural log of x cubed. And we're going to do this in two different ways. First way is we're going to use the chain rule like we've been doing. And then the second way, we're actually going to use some log rules first to simplify the work that we have to do. All right, so let's look at using the chain rule. So when we have y equals natural log of x cubed, we have an outer function of natural log, and then we have an inner function of x cubed. At your desk, at home, go ahead and just take a guess if you're not sure. Try to find the derivative of y equals natural log of x cubed using the chain rule. Okay, did anyone get an answer for the derivative dy dx using the chain rule? No, good question, Adam. This is not a product, right? It looks like a product, but the natural log, the ln symbol there, that is not a variable. It's an operator. It's telling you to perform an action on the x cubed. So it is not a product, it's a composition. X cubed has been plugged into the natural log of x. So that's why we're using the chain rule and not the product rule. In other words, maybe this will help. We're trying to find dy dx, right? But don't think of this as natural log of x cubed. Think of it as natural log of u. All right, so dy dx is going to be the derivative of the natural log of u is 1 over u. But since that's not an x, since the variables don't match up, that's times du dx. Okay, but u is really x cubed. So repeat that process, but do it with x cubed instead of u's. So still using the rule, derivative with respect to x of the natural log of x is equal to 1 over x, or written in u notation, which incorporates the chain rule, derivative of the natural log of u is 1 over u du dx. This is what we're using. Good, that's the first step, 1 over x cubed. That's right, so we're going to have 1 over x cubed. But since that wasn't just an x there, we have to multiply times the derivative of x cubed. So it's going to be 1 over x cubed times what? 3x squared. Good. So we can simplify a little bit. So we have dy dx equals 3 over x. Okay, so that's one way to get that derivative. Perfectly valid way to get that derivative. All right, now let's look at using the power rule of logs instead. I'm gonna scroll up. Remember what the power rule of logs says. Whenever you have the log of x to the p power, you can bring that power out front. You still have an equivalent expression. So down here, we're gonna start with y equals the natural log of x cubed. But instead of going ahead and differentiating, as we often do, we're going to rewrite using algebra, specifically the power rule of logs. So instead of y equals natural log of x cubed, this would become y equals what? Very good, 3 natural log of x. All right, so notice we have not done any calculus. We haven't differentiated. We haven't taken the derivative. So now we're going to differentiate, and we're going to have dy dx equals, the 3 is going to stay the same. And what's the derivative of the natural log of x? 1 over x. That's right. Boy, that looks terrible. Let me rewrite this. So we have 3 times 1 over x, which is just 3 over x like we found a minute ago. So we were able to avoid having to use the chain rule by applying a rule of logarithms first. But we got the same answer either way. So again, it's just more tools in your toolbox. Okay, so now let's look at this one, which is what we're going to do in the next video. If you found this video helpful, please give it a thumbs up. That will help other students to find the video.